better maybe. So there's over 300 articles on there. They're sponsored by the Grain Commissions of Western Canada and Ontario. So that's just a little, I'm not here to promote this, I just want to make you aware of where we're from. Jason and I have been independently working on the drone issue and have been doing experiments together and also speaking with others about drones. As you know, Garlon XRT, I'm never quite sure what the 3 letters are behind the Garlon product. XLT, XRT, it's one of those. Has been approved. It's the first herbicide to be approved for drone application in Canada. It is not an agricultural use. It is a rights of way and rangeland use. It is for woody perennials. And it's the first one. So we're all watching it. On the other hand, so it's basically illegal to spray with drones based on those registrations. We know that. With drones based on those registrations, we know that. The provincial government has issued a statement to that effect for producers. Nonetheless, we estimate that there are about 300 spray drones operating in Canada in the gray market. Okay, so they're selling like hotcakes. They're affordable. They're used in the US legally, and they're used in Canada illegally. So it's just a question of your comfort zone with that, but you may know someone who has a spray drone, and they may just be trying it out, and they just may be frustrated with the pace of progress. So spray drones are interesting. They are a departure from traditional spraying, and that's the main reason why the PMRA, our federal regulator, has been reluctant to give a green light to them. They say we don't know. They're different from aircraft, manned or piloted aircraft. They're different from ground sprayers. They're different from air blast sprayers, and I agree with them. So we have to assess those risks, and the risk assessment process takes time. The risk assessment process is also driven by registrants, which means it doesn't matter what the PMRA thinks. A registrant will have to bring forward a product that they would like to see labeled for drone application. And they will have to provide the data, and they may not do that. So we may have a few here and there, we don't know. We have one. There's a few in the pipeline. I'm not privy to that information, but I have a hunch of what they are. But there's not a lot in the pipeline, I can tell you that much. So if you think there's going to be a blanket, go for it statement for drones in the near future, you're mistaken. We're going to go one by one for a few more years, and maybe there will be a grandfathering in of drones to current aerial labels if they find them to be sufficiently similar. That's a potential. Okay. So here are the issues. There are significant issues. Let's talk about them. They do provide a niche. I don't have to explain that to you. You can take a drone to a site and do a small area with it that would be much more efficient than doing the same with a ground or an aerial sprayer. You can reach areas that are difficult to reach, wet spots, et cetera, et cetera. So there's a logistical niche there. They have very legitimate regulatory hurdles and technical hurdles, and we'll talk about those. And as I said, they do require that support. I don't believe that we're going to have, like, for example, if a company doesn't want their product to be applied by air because it's a headache for support, it probably won't be registered, and nobody's going to register it on their behalf because they'll have to look after the mess that it creates. The technical hurdles are as follows: water volume, spray quality, canopy penetration, deposit uniformity. All of those are challenging, and I'll explain to you why that is. Drones must apply less water. They have the largest drone that we did a trial last month, Jason and I, in Ontario. We used the latest T50 drone, the DJI T50, the largest drone DJI makes. It has a 40-liter tank. 40 liters. Okay, 10 US gallons roughly, 10 or 12 US gallons. So if you want to do anything with it, you're not going to be putting 10 gallons per acre on. The atomizers also have a hard time putting that much on. They're not designed for such high volumes. So even if you want to, it's going to be very difficult. Most people will have drones fly fast and use less water, little water, 2 gallons maybe is sort of the norm. That means you must use small droplets to get coverage. Our benchmark for coverage from the ground world is about 80 droplets per square centimeter in terms of density. And you're just going to get there with 2 gallons and a relatively fine spray. You're not going to have any excess. In ground spraying, we can do hundreds of drops per square centimeter if we want to. It's quite easy. But we're just on the margin of where it's still going to work. So you have to use them, or you have to risk having insufficient density, and that is efficacy dependent. So here's just a visual. Is the middle button the?
I don't think there's a.
There is none. Okay, that's fine. So at the top, you see a row of ground deposits, and these are all at 10 gallons, excessively good coverage. And then we're moving to coarser and coarser sprays to the right. And in ground spraying, we've been able to take advantage of that feature by moving into coarse sprays as an average for deposition, which is beneficial for drift control. It's beneficial for widening the window of operation under marginal conditions, perhaps. It has a number of benefits that are environmentally neutral. They don't increase risk. With a 3 gallon per acre, we have a deposit that looks about like that, plus or minus. And you can see there's not a lot of room to move. If we went to a coarse spray here, we would have insufficient numbers of droplets. So that is going to be an issue. Another one is compliance. New drones now have rotary atomizers, and the rotary atomizers do not have droplet size data available for them. Yes, they have on the monitor. If you apply DJI T50, you can select a medium or a coarse, a category of coarse that you would standard. And these new rotary atomizers have not yet been medium defined, even though they say coarse. And so if you have a label requirement to spray with a medium spray, you may not be able to do it if you have a rotary atomizer. And if someone says, did you spray with a medium spray? You'd say, I think I did, but you probably didn't. Right? So that's a problem. So difficulty in complying with the label. Another thing that's interesting here is the canopy penetration aspect. This is some work we did last summer in Ontario near Blenheim. And this is a T10 drone. As he was flying, I just took a little video. This is in slow motion. And the corn stover is just absolutely flying. I mean, they have a tremendous amount of downforce. So that's actually beneficial. We'll talk about that too. Coverage-wise, you can see that the coverage here, we see sort of the bottom of the leaf is the blue, and the top is the other color. You can see, obviously, you get some, sorry, it's not the underside of the leaf, it's lower into the canopy. This is Jason's data. You can see that there is a loss of penetration, but typically, the loss of penetration is about 2/3. That's what we typically see in a canopy. And it seems to hold roughly true even for drones, even though they have that air assist. So they have that advantage, but I'm not sure if we're going to harvest all of it. You can see that there's less coverage with the 3 and 5 gallon per acre drone than was with the 16 gallon per acre ground. And this is just assessed by area covered on a water sensitive paper. The biggest issue that I see is the swath width and uniformity issue. So we've done hundreds of these over the last couple of years, and it is just basically an aerodynamic nightmare. So what we typically do is we'll put on a track and we'll fly a drone across it into a slight headwind. We go into a headwind because if we had a side wind, it would blow so far off the track we wouldn't be able to capture it. The liquid has a dye in it, and this dye leaves a blue stain on this. This is receipt paper from Staples. But you can see the droplets, although they are, this is a typical thing, so they're not high density. And you can also see the droplets are smeared in different directions based on the turbulence that the rotors have generated. And so that is certainly something that we're watching. We have a scanner, and we run this receipt paper through a scanner, and it counts the droplets and measures their coverage, which are very useful. We follow guidelines that I'm trained in, which are Operation Safe calibration clinics organized by the Canadian Aerial Applicators Association. We follow the basic same guidelines. You lay out a swath that's about twice as wide as your expected swath width, because things move, and you fly into a slight headwind. And you fly at the height that you expect to spray it, et cetera, and then you pick up these cards or these deposits and you scan them and you count and measure droplets, and then you make a graph out of it and figure out how it all looks. The new thing, the continuous sampling track is relatively new. It's called the Swath Gob. We bought a couple And they make it really easy. But the average producer is going to have these, right? So you have to basically consult with an expert to find out how wide the swath is. Remember, the issue is this. If you have a 120-foot boom on a ground sprayer, how wide's your swath? 120 feet. If you have a DJI T50, how wide's your swath? Nobody knows. We've measured swaths from T50s that are 4 meters wide and 10 meters wide. It depends how you operate them. So your swath width and the spacing that you have with adjacent passes is absolute. And so you have to find that out. But most current users are following the one statement on the DJI manual, which says swath width is 9 feet, 9 meters. And they set it to that and they go, and sometimes it works out and sometimes it doesn't work out. So we basically reduce the density to a 1 meter or half meter interval. Makes it easier for us to handle the data. We can capture way too much data with this continuous scanning. By the way, look at the large droplets on that particular piece. That was last fall. We did that in Simcoe, and we tried to do 5 gallons per acre with the drone, and the rotary atomizers couldn't handle it, and they flooded. So those large drops that are not supposed to produce those just ran over the edge of the rotary atomizer in huge gobs and landed on there. So that's a waste of inefficiency. So there are technical limits to how well they can do. And there are so many variables that we basically, we came to some conclusions which I'll share with you, but it is very difficult to just step out onto a field and say the swath width is going to be 6 meters. Honestly, you just don't know. Right, so you pretty well have to do this more than a few times. One example. We flew a drone into a headwind, and then we just turned around and flew into a tailwind. And each time we measured 3 swath widths. And into a headwind, it was 4.4 meters, and with a tailwind, it was 2.9 meters. So just that aerodynamic difference narrowed things up quite a bit. So if you're flying and you pretty well have to take a side wind to keep that wind factor consistent. That may or may not be practical on your farm. I'm going to show you about 5 or 6 graphs now of what deposits look like. So don't be scared, but this is in fact terrible. So we're flying. This is T30. This is a drone that has 12 hydraulic nozzles on it, not rotary atomizers. We use XR11015, so that's a medium to fine spray. We went 1.5 meters off the ground. It's too low. That's why it looks like this. We flew 5 miles per hour and 5 gallons per acre. Okay. So this is with Michael Reinke. We're collaborating with him. He's Michigan State. And you can see a bimodal pattern. That happens when we fly too low. Basically poor patterns. So you have a peak under each bank of atomizers. When we went to 3 meters high, it became good. Now, believe it or not, that's a great deposit from a drone. Okay. And then we went to 10 miles per hour, and you can see now that the swath widened a little, and you can see the little tiny droplets on the edges here. So they do exist. And I wanted to show you, this is 10 miles per hour. We laid out three bands of collectors. So there would be one where I'm standing, there'd be one at the end of the room, and then one again that much further. And so one pass, we deposit all 3, but they're separated by 10 meters. This is rep 1, so this is the first one. And exactly 2 seconds later, oh, I gotta wiggle the battery, right? Exactly 2 seconds later, the battery wiggling is not working. We got this, and another 2 seconds later, we got that. Yeah, maybe, could you? That'd be great. Then I can save the microphone. We're getting close to it. So just look at the variation in a single pass. So of course that's alarming. Next slide. And we went then to 16 miles per hour and 2 gallons per acre, basically, because we're going so much faster. And we lost control of that deposit. It just went kind of sideways on us. So that's the issue. So if you spray the same way each time, obviously the amount of error or offset is going to be similar if the weather doesn't change. Half meter or 1 meter intervals, and that's a typical pattern that we see. And we developed a next slide. Then what we'll do is we'll add them together, adjacent swaths. We want to know how wide can you spray. And the principle is as follows. You determine the top of that deposit, That's what your goal should be. And then because you have these trapezoids, these walls, you go halfway down. And so that the point where they overlap, that should be then about right. That's the theory of it. So what we'll do here's we've calculated a few things like coefficient of variation, underdosing, overdosing. The first thing we do is we do the dashed line at the top. We say, what's the average maximum deposit? It's usually the maximum minus about 10 or 15%. There's usually a peak that's a little higher than the rest of them. So we go there, that's a bit of a judgment call. And then what we do is we tighten up the swath until we like the numbers. So if you go to the next slide, I'll show you how that works. So here's your 10% line, and here's your, we did it, that's the number that it is. It's a 3.1 is what the number is if we just calculate that. Next slide. And then we have a swath width number that comes out, which is the distance on the x-axis. We just keep changing that with our little button. So keep going. And then we get an underdose and overdose estimate. So for example, right now, almost everything is under the dose that we've drawn a line at, and almost nothing is over. Next slide. And then we tighten things up until things get a little bit better. So that's now 8.5 meters. Still the majority of it is an underdose. So keep going, please. Thank you. And then we go a little bit too narrow, and now everything's an overdose. Okay, so now we're wasting material. And also the swath. And then we find the happy medium. So we just hunt. We hunt for it, we look at the numbers, we look at the graph, and we figure that out. This is exactly how it's done for aerial applicators. They bring a specialist in, they fly the pass, they collect the sampler, they have software similar to this, and they tell the applicator your swath is 65 feet on this aircraft, okay? And yeah, we look at the numbers, and you can go other ways. If you go to the next slide, there's one more. You can also still have that same, lower your average and sort of accept that you're overdosing, underdosing a little more, but what that gives you is a wider swath. But now you have the potential of striping. Okay. Next slide, please. So in the bottom line is as follows. When we are too low, we get this bimodal swath, okay? Swath is a little, and I guess the bimodal part of it isn't actually on this slide for some reason, I took it out. If we go into a headwind, it widens, keep going. If we have a side wind, it moves off to the side, it becomes less uniform. And we have to basically offset that. And go to the next slide, offset that, and it moves over. And that's normally done for aerial applicators anyways, the drift. It's fairly significant. Okay, let's keep going. So here's some aerial shots taken by Steve Lee. So Steve Lee's a professor at Auburn, Alabama, one of the leaders in researching drones. If you look at the top, they flew a little bit lower. They flew from left to right. And you can see the wind was from what I would call the south, the bottom, and the northern, the top left quadrant. You can see there is striping in between the swaths. But you can see there's some off-target movement. In the bottom quadrant, they flew higher. So they got they had significant movement off target with the south. So, it kind of looks like that. Next slide. Yeah, that's Jason's comments. What Jason then did on his own, this is without me and I'm borrowing these from him, is he thought, well, does the swath change in a canopy? Because we might be testing it on bare ground, but what if your forage crop that you're spraying into is tall or whatever, what happens then? So he did this in wheat and soybean, and 8% reduction in the swath width. So swath narrow zones given this variability. Right. Next slide. So here's another one from Steve. This is a desiccation, and you can see the striping in corn, and it's a serious disease, causes leaf necrosis. It's very visually impactful, but fungicides are quite effective on it. He calls it as living water-sensitive paper. If you have a bad swath, you'll see it in the necrotic, the brown spots, and it'll be visible from the road. So he's got some areas doing tar spot and sort of saying, like, this could be better, we need to do that. So it's not going to just disappear. Yeah, next slide. Here's another one. This is something we borrowed from Dr. Sean Askew in the US, the boundary accuracy. And the white box instructed his applicators to spray it with. On the left is a drone, which just walked around the perimeter holding the handgun, staying back and forth with it. Right? The typical way, actually, to be honest with you, that we'd see industrial sensitive areas, it will be a little bit more difficult to comply with those because we just don't know the drone application. Because it kind of just peters out. Where do you draw the line? Next slide. Just some more stuff from our wheat head deposit work. So as you go faster, you can see the density of droplets on the wheat heads, and that's part of the swath. You're diluting it because. Next slide. Work that Jason, more of a messy slide, but is he went to the top of the canopy, the upper bottom of the canopy, groundage, and that I think has some value. In the canopy that might be difficult to reach for traditional spray. I do think that it had this in common, and any of these are significantly different from each other. So there does seem to be a general observation that nozzles or hollow cones or coarse nozzles, or I believe one of the last things that I'll show you. This is something that we did in Simcoe at Jason's research for Simcoe. And this is also the direction probably the air is moving, which is the strong air blast creates high pressure, and it has to go somewhere. So some of it goes to the front and back, mostly to the back because the drone is actually tilted forward a little bit because it's moving forward. So most of it is shot out the back. That's okay. So then when we look at example back and we're watching the drone spray. So this is now 12 meters usually. We did this a whole bunch of times, but it's in these two regions where stuff is coming back. So it's complicated. XAG 100 Pro. We did this 2 rotary atomizers. This is also a 40-liter drum. No one sprays 5 gallons. No one flies this slow. But I want you to see, because we had the dye in there. It's fine. I don't know. He's a farmer. Okay. Okay, I'm going to call him. He called me up in the winter. He called me up in the good drone. He says, I'm going to buy, because, 35,000. And I saw him this summer and I said, how did it go? And he said, I bought 2 drones. That's great. He was happy at that time. License and certificate. It's typical. It's hard to get. To share airspace with spray planes. He has to be on the radio with the time. He has to know where these spray planes are. He can't fly. And then next slide, and we'll finish off here. This is the case. This is in Ontario. This is beans, dryable beans, and the green. The numbers are public knowledge. You can buy a T50 for $40,000 with 3 batteries and all the doohickeys right now. Okay, about productivity. Right. So that's attractive. Next one. We will be going to the water bodies. There's no question about it. Okay, next slide. Last slide. So that is starting to happen, and time will tell. I mean, if situations, I would say stop doing that. Because drones are not around, not for us.
The regulation, is it like the farmer has to sue their neighbor because they sprayed it, or how does that?
The provincial and the federal government is responsible for enforcing the law. Of course, the label is the law, that's federal. And then the province has its own supplementary restrictions that they may impose. For example, we do have that for waterways and proximity to